Most of this video is kind of going to be a second round of the previous video. I tried to pick a little bit different examples in some cases where you'd see a fresh example of how to do some of our concepts and vectors. Just pause if you need to. Some of the stuff we've already talked about is dot product, finding the angle between two vectors, determining whether two vectors are orthogonal to each other. That's when the dot product is exactly zero. We also looked at direction angle. I don't have that in here, but the formula for direction angle is tangent theta equals y over x. It's the rise over run tangent inverse of that ratio. Let's get it. Let vector u be 3, negative 4, and vector v be 4, negative 2. We're going to find the dot product and the magnitude of each vector, and then we're going to use those values to compute the angle between the two vectors. U dot v, remember, first entry times first entry. It looks a little deceiving because there's a couple of negative 4s, but it's the first 3 times this first negative 4 plus negative 4 times negative 2, the product of the second entries. Negative 12 plus 8, that's negative 4, and that tells us we've got an angle that's not 90 degrees. We're going to determine that here in just a minute. The length of vector u, 3 squared plus negative 4 squared, that's 25 square roots to 5. Not all of the magnitudes come out friendly like that, and vector v is a case of that. Because it's in component form, negative 4 squared plus negative 2 squared, that comes out to 20, and square root of 20 is not exact, so we leave it square root of 20. To find the angle between the two vectors, we use the fact that cosine theta is equal to the dot product over the product of the magnitudes. So that's negative 4 over 5 times square root 20. Anytime you need an angle, use the trig inverse. So cosine inverse of this big fraction, carefully type it in, is 100.3 degrees. Vectors in unit vector notation, that's with the I and the J. You want to keep the coefficients of I and J in order. Then you can write it in component form. So vector U is 1, 3. Vector V is 4, negative 1. U dot V, that's 1 times 4 plus 3 times negative 1. And that gives us a value of 1. So we know we're not dealing with a 90-degree angle. Magnitude of U, that's a square root of 1 squared plus 3 squared. That's square root of 10. The magnitude of v, square root of 4 squared plus negative 1 squared, that's square root of 17. Cosine theta is equal to your dot product over the product of your magnitudes. Square root of 10 times square root of 17. You can write that as a single square root of that product, 170. Cosine inverse of that fraction gives us 85.6. And that's the angle between the two vectors. Let vector u equal 3, negative 4, and vector v equal negative 4, negative 2. Both are in component form. Find the magnitude of 3u. Well, over to the upper right of your screen, the vector 3u in component form is 9, negative 12. It's 3 times the length of vector u. The magnitude of 3u, if you go with component form, 9 squared plus negative 12 squared, that's 225. Square root of 225 is 15. And so that's the magnitude of 3u. Here's another way to look at it. If you find the length of vector u, which would be 9 plus 16, that's square root of 25, which is 5, you can just triple the original vector's length. So it's a kind of a pay now, pay later deal. You can either triple the length and then find magnitude, or you can find magnitude of the original and then triple that value. Underneath, we have the magnitude of u plus v. Let's calculate u plus v, and then we can find its magnitude. Vector u plus vector v. You're going to add your first entries, 3 plus -4, that's -1. Then add your second entries, -4 plus -2, that's -6. Once you know component form, to get magnitude, you're going to square each number, add them up. -1 squared plus -6 squared, that's 37. That's a prime number, so no way it's going to square root nicely. Square root of 37, this is called the inequality property. Unless the only way they're equal is if u plus v is u plus v, where both vectors are pointing in the exact same direction. If they've got any kind of misdirection from one another, then separate magnitudes will always add up to more than the resultant vector. And so let's check it real quick. This left side is square root of 37. That's just barely more than 6. The length of u is 5. The length of v is square root of 20. Well, that's between 4 and 5. So if you have 5 plus a number between 4 and 5, that's already in the 9 to 10 region, which is way more than 6 something. And for our final example, this one is sort of a revisit on direction angle. It never hurts to do more than one example. Let's let vector v be the vector 4i minus 2j. In component form, that's 4, -2. The magnitude is the square root of 4 squared plus -2 squared. That's square root of 20. When you only have one vector, and so 4, -2, we start the origin, go out to 4, -2, and that's our vector in component form. Direction angle is the angle from the positive x-axis counterclockwise to your vector. Tangent theta is equal to y over x. For this problem, that's -2/4, which is a -1/2. Tan inverse of -1/2, using your calculator, is -26.57. Now remember, tan inverse, we're restricted to the right side. Quad 1 and quad 4, specifically quad 4, you have to open negatively. So this blue arc here and this blue reference angle, that's the -26.57. Now, the angle we really need is this one in red. So if we take a full rotation, which is 360, and backtrack it 26.57, that gives us a direction angle of 333.33 degrees. Let's look at this vector one more time, 4, -2. I'm going to leave the graph of it showing. There we go. I want to try to give two vectors that are orthogonal to this one. Now remember, they need to have a dot product of 0 in order to be orthogonal. This vector is 4, -2. So look here, recall vector v in component form is 4, -2. Now if I need to get my dot product to be 0, I need to come up with an arrangement so that first times first plus second times second are the same value but opposite signs. The easiest way to do it is reverse the order of your numbers, but only change one sign. Now, what I mean by that is I swap the order and I take the negative off the 2. This is one vector, 2, 4. And think of it, if I go to 2, 4, follow my highlighter, from the origin to 2, 4. That makes a 90-degree angle with this vector. My other option would be to reverse the order and put a negative on the 4. And that gives me a vector -2, -4. Follow my highlighter. -2, -4. From the origin to -2, -4. That's also forming a 90-degree angle with vector B.